Thank you for being here. It's a great experience to be here on the podium and be a speaker here. My topic today is going to be about Pulsar's journey at Boomi. Let me just introduce myself real quick. So I am Shravan Narayan. I'm a principal software engineer at Boomi. I've been at Boomi for about 4 years now, in which time I have been with the connectivity team and also with the event streams team now. I live just outside of beautiful green Portland, Oregon, where I love to play cricket when it is not raining, and when it is raining, which is most of the times, I love to go on hikes with my dog. All right, let's dive straight in. Just before we go any further, how many of you have heard of Boomi and know what it does? Nice.
I know.
Oh yeah, thank you. He's my colleague. He has to know. All right. Before answering that question, let me ask you one more question on what do you? Oh, I think these are slides from the previous presentation, but we'll make do. It's okay. All right. I was going to ask if you also have heard of this term called iPaaS. I'm sure you all must have heard about PaaS. What's different with what's special with the I? That's correct. So iPaaS stands for, it's an online cloud service platform which helps you, connect, govern, and deploy your and connect your integration flows between any combination of on-prem or be it cloud-based services, application processes, or basically any data systems, either within the same organization or across organizations. That's what Boomi does. Boomi is actually the pioneer in iPaaS space. It touts the largest customer base of about 20,000 customers the last time I checked. And I promise this will be the only marketing spiel I'm going to use. If you want to connect everything to everyone to everything, anywhere, you might want to think about Boomi. All right, moving on, as I said, we are in the cloud integration space, where our customers mainly expect us to support 3 different patterns, right, which are data-driven, API-driven, and event-driven integration patterns. It's not just that they need or their solution demands just one vertical here. It's actually either a combination of these or all 3 integration patterns developed together to solve their integration necessities. But overall, we have seen that the overall industry has shifted towards the right, towards the event-driven integration from data-driven integration over the years. And that is what I'm mainly here to talk about. What does Boomi do and how does it support event-driven integration, and how it uses Pulsar to do that. Yeah, again, as I said, these are probably the older slides. I'm going to skip through this. I'm going to talk about what is the existing problem that we have in the EDA space, and what is the problem or what is the solution that we have worked on. Boomi's approach to supporting EDA or event-driven integration has been twofold. One is that we have a rich ecosystem of connectors that we support, right? That is the core strength of Boomi as far as I'm concerned, right? We develop and support connectivity that you can connect to any of these cloud providers or even queuing providers platforms, such as you can connect to SQS, Google PubSub, Azure Service Bus, Salesforce, Solace, whatever, right? RabbitMQ, Kafka, we all have connectors for that. So one approach was, why don't you as customers bring your own messaging middleware and we'll help you connect with it, and then you can still use Boomi's entire platform and build your solutions like that. But the problem or the main issue with that was we were not necessarily solving the problem of supporting a real-time integration experience within Boomi. We were kind of pushing away that problem to the customer and saying, hey, why don't you go and buy a new service or a new or stand up a new system which comes with its own complexities of maintaining and costs, right. And I mean the bigger problem was that this is kind of counter to Boomi's philosophy of having to provide a single pane of glass for all of your integration needs. The other solution, as I mentioned, was we have a legacy queue or a event broker solution called the Boomi Atom queues. Atom is our runtime engine, which has an inbuilt queue or a broker built inside of it, and hence Atom queues. But it has severe shortcomings in it. It being it was not scalable, it was not highly available. There were no messaging guarantees of message delivery guarantees. There were no message ordering, and there was very limited external connectivity to third party systems, and messages could not be sent between accounts, environments, or even runtimes, right, because you are captured within the same runtime environment that where you are running your atoms on. And if you are a global company, there was no multi-region support as well. So how did we go about solving this? The solution lies in Boomi event streams. Launched in May this year, it is Boomi's solution to event driven or to supporting event driven integrations inside our ecosystem. It is and Flash News, it is based on Pulsar, right. The main benefits that we get out of it is, it addresses all of the main pain points and all of the problems that we were having with Atom queues. At the same time, it provides and it makes sure that the customers don't have to invest in an external system, and it leads to and it gives them the best in class performance without leaving Boomi's ecosystem, and that's got to make the product folks happy. Overall, now this is how the this is how our ecosystem looks like. It's a pretty typical event driven architecture, but the only difference being you have your producers and consumers on either end of event streams, which is powered by Pulsar. Those producers and consumers can be any combination of on-prem or cloud-based services, applications, and processes. I'm going to skip through this too. This was again one of the limitations that we had before, was that we could not have multiple consumers listening on a single topic, but with Pulsar we can do that because of the subscription model that we can attach to a particular topic. All right, I think by now you probably have a good idea of what Boomi is and how we are using Pulsar within Boomi to address some of the existing shortcomings with the legacy solution. Let me just walk you through some of the main reasons of why we chose Pulsar and how we actually ended up, or how we took that process successfully. In the beginning, the scope of choice of a backend backend messaging broker was quite open. We did a pretty exhaustive tech evaluation comparison between Pulsar, Kafka, Solace, RabbitMQ, ActiveMQ, and so on. And we approached at this comparison based on 40 different requirements that we had collected, either from customer feedback or from the vision that we had in developing a native event-driven integration, or what does a native event-driven integration require. So I know we all try to be objective in the very beginning, looking at this problem of why Pulsar, but I remember some of us towards that end of that evaluation had moved over to convince me why not Pulsar camp. I just want to talk through some of the sections and requirements and which we were looking for in a messaging solution, and maybe I can draw parallels of how Pulsar meets most of these requirements, right? The first one was deployment and admin flexibility when it comes to a Pulsar. We wanted to also host this solution within our platform, within our private cloud. So ease of deployment, and if the solution was cloud native or not, how Kubernetes friendly was the deployment going to be for scalability reasons, and how easy was it to deploy on premise versus versus, and also how easy was it to be able to deploy in multiple cloud providers. And if I am deploying it on premise, how easy is it to connect to that cluster, talk to that cluster from an administrative point of view. The other section that we looked into was connectivity. As I said, we wanted the solution to be supporting most of the open protocols out there, and I have an auto power off window on the monitor here. If you can switch it off, it says that this monitor is going to switch off in 60 seconds. Sorry, coming back to it, I might just want to look at the slides in that case. Right. So the next set of requirements that we looked in was how extensible and how flexible are the admin REST-based admin APIs, because we were going to develop a solution on top of Pulsar to be interacting with it through the REST APIs and to create, produce, and to basically manage the life cycle of Pulsar resources, topics, messages, subscriptions, so on. And also what was the breadth of client libraries that were available out of the box, and how easy was it to also come up with a client library for a non-existing language. Maybe, I mean, the most popular ones are of course Java, Python, Scala, but we didn't want to exclude a customer who would want to write in a library which is I don't even know, like WebSockets maybe. The next criteria was, what are the different messaging patterns, what are the different EDA messaging patterns that the solution provides and is capable of supporting without doing much tweaking with it, right? Of course, the point-to-point, one-to-many, and fire and forget kind of capabilities are pretty standard ones. And other than that, as I mentioned before, as I showed in a clip before, is it capable of supporting multiple consumers processing a stream parallelly on a particular topic? How well is persistent versus non-persistent messaging supported? Is the delivery, or is the message delivery guaranteed, and if the message order is also preserved? That was also something that we were lacking in our previous messaging solution. And how is the retry mechanism structured? How often can I retry a message before it goes to a dead letter queue? And first of all, if there is a dead letter queue support or not, and is there any in-stream messaging, native in-stream message processing support, or how easy is it to connect to a third-party in-stream message processing system? The next one is probably the most important one, and the one that we spend more time on deciding. We are a multi-tenant company. We have about 20,000 plus customers, as I mentioned. So we wanted to invest in a solution which treated multi-tenancy as a first-class citizen, instead of having a layer and making a solution look like multi-tenant. If again we wanted to see if a solution supported multi-region replication, if you wanted to have your data replicated across multiple regions. For our higher grades of customers who have lot of data and wanted to support a typical streaming use case, is tiered storage, and storage of data for longer term, is that supported out of the box or not? We also went in with we knew that we wanted to go in with an open source version of any technology that we chose, but we also were quite aware that most of our needs, or if a particular requirement was not met, we wanted to see how extensible is the plugin ecosystem and how easy is it to develop your own custom plugins on top of it. Again, non-functional requirements of being highly available and to be able to recover your data in case of a disaster, were also high up on the list. So, overall, towards that end of that process, as I said, Pulsar evolved as a clear winner amongst all the other messaging solutions that we evaluated. The main highlights or the main reasons why for which we went in favor of Pulsar was that it is probably I don't want to say the only, but the only cloud native out of the box messaging solution. Its decoupled architecture makes scaling very easy, and that is kind of its unique feature in terms of compared to other messaging solutions that we evaluated. It has stateless broker, right? And if a broker, that means that bringing up a broker, getting rid of one that is misbehaving for some reason is pretty seamless and easy. As I said, we have different tiers of customers, for which we needed to support both queuing and streaming in the same product. Pulsar is probably the only one out there which gives you both streaming and queuing functionalities coupled into the same product. The next one is my kind of the favorite one, segment-based distributed ledgers. Write-only logs are great to act as an abstraction layer for real-time data exchanging systems, and it gets away with a lot of interactions with the persistence layer. But what happens when that particular log balloons out of control or it has a lot of data? And I mean, what happens when the server goes down that has all those logs? Of course, a new one comes up, but that takes time, and resources are kind of locked off until it comes online. So, but Pulsar's approach to breaking down these logs into segments and spreading them over different servers is kind of unique, and is what caught my attention. Multi-tenancy, I think I have mentioned on that one also. That's also a big positive as far as Boomi was concerned. The next one is again performance. You obviously want your messaging system to be highly performant, to have high throughputs and lower latency. But what we saw during our benchmarking performance tests was we could see consistently high throughput with lower consistent latencies, and that's a good combination to have, I believe, right? You don't have to trade off as much with higher throughputs with increased latencies. That's a pretty unique and nice feature to have. And overall, it was an easy sell upstream and to get everybody on board and to start adopting Pulsar within the organization. All right, let me just talk about what we have built real quick. Right, we are taking advantage of Boomi's multi-tenancy out of the box. We have mapped our individual accounts onto a tenant, onto a complete tenant. So every customer, a customer can have multiple accounts in them, but you can say a customer gets their own tenant within Pulsar. And Boomi has this concept of environments where you can design your processes and deploy it on runtime. You can also attach multiple runtimes to an environment. So in DevTalk, they are pretty similar to how you would structure your dev, QA, prod clone, and production environments. So that worked, or that hierarchy of a namespace sounded pretty much similar to what we do with our environments already. So that was an easy map as well. And below that, we took advantage of how topics and subscriptions are structured and how you attach your consumers to a subscription instead of directly to a topic. Moving on, this is the actual tech stack. I just want to say we evolved over this and have kind of settled onto this solution over time. We started off with a early access phase where we took in inputs from our customers, a handful of customers, built on their feedback over and had a technical preview, and we are in GA since May this year. Our tech stack mainly consists of on the right, you would see the Pulsar cluster. Again, we host everything on Amazon, our own private cloud. What you see over here is the stack for just one region, and we have multiple regions where this Pulsar cluster is deployed to. As you see, we have a Pulsar cluster here. The users can directly interact with it with a token based authentication that's again we have generated on our UI. I'll talk about that in a bit. Over the Pulsar port, over the 6651 port that is open to the internet. The other port is where the REST admin port 443 is being used by our admin service, which handles all the business logic and all the interaction that happens with the UI, to create topic resources, check your backlogs, etc. Along with that, we also have a couple other microservices. I'm going to talk about them in a bit. They're just called Polar and Query Service. We also built an integrated dashboard within our UI. Pulsar comes with Grafana dashboards, which are great for administrative purposes, for somebody who is monitoring the cluster. But we wanted to build something for our customers who could see all of their activity of their messages, in different environments and different regions on a single page, and have a graphical interface for that. So, and this is where we are using those other two services, Polar and Query. A quick look at how things work in the back end. We rely on Pulsar's metrics, detailed metrics that are available to us. The Polar service polls different regions of Pulsar cluster, grabs these metrics on every 10 seconds or on a schedule. It just grabs that and puts it onto an internal Boomi bus, which is a service bus or just a message topic. If you want to think about that. From there on, there is a metering ingestion service, again a small microservice hosted on Kubernetes, that grabs data from this internal bus, converts it into a time stream format and pushes to time stream DB, from where any calls from the UI the time stream DB acts as our data source from this point on, and any calls from the UI to pull data and show are being surfaced by the query service. We also use the same, I think I'm missing a slide here, but we also use the metrics provided to us by Pulsar cluster to charge our customers and to bill them. We are one of the first services within Boomi to actually start charging customers based on a usage model. So we grab these again, the metrics which are tenant, topic, down to the subscription level, and feed it to a data warehouse where we perform usage based quotas, and then alerts are being sent out to customers and to mainly to our sales and product teams to monitor their usage patterns and reach out to customers for any upsell. Again, it's just an example of how what Pulsar provides and how we are using it for our custom needs within Boomi. The next piece in our implementation is the event streams connector. This is the vital piece, this is the vital cog in the wheel that links our backend Pulsar clusters, which are behind our firewall, and the outside world, and basically Boomi as a whole. Our customers use this to build a process which is a logical flow of data between their systems, and they can use this and they can use the connector to basically determine which topic to publish to or to consume from. Every connector within Boomi has two components, the connection and operation. The connection component has the connection component, all it needs is basically a namespace level token which we generate for you per environment. So every namespace has a token. It has the jar token for authentication and authorization in it. It also has a service URL and the account ID and environment ID. So it's basically everything that you need to start pointing at a particular topic and perform either listen, produce, or consume operations. Again, as I said, those three operations are highly configurable. For your produce, all you need to know is what topic. You can also leave this blank. Pulsar auto creates it for you, and you can choose between shared and exclusive access modes when you're trying to produce to a topic, right? And you can also determine if you want to choose a message compression type or not. When it comes to listen and consume, again, you just need to know your topic name, subscription name, and type, and you can also configure retry mechanisms and if you want to consume from DL queues or not. Moving on, I think I spoke about this already. All right, so we have now, so far we had built out a pretty good suite of products on top of Pulsar, but we hadn't really done any sort of performance tests so far to have a confidence in supporting production loads. So, but our use case was slightly different in terms of what's available in the open source world. Our average payload size that flows through Boomi is about 5 KB, but we just did not want to go by that number, so we ran different scenarios of performance tests with 1 KB, 64 KB, and 5 MB of payload sizes this is our approximate first year estimate that we went with in these tests. We created 550 plus tenants, 1500 plus namespaces, 15,000 plus topics, which had 5,000 concurrent producers and 10,000 concurrent consumers. The testing was again split in two phases. One phase we were directly testing the cluster, and the second phase was we were more or less running the same scenarios, but we were generating the load and consuming the load through our connector, which is again packaged and deployed onto a runtime. This was kind of important for us to test because we didn't want to saturate the runtime by having a pretty heavy, if there were bottlenecks we wanted to know, and if there was a high data payload that was passing through the runtime, we didn't want to saturate it and break it, because that's being used by other services as well within Boomi. Just talking briefly about the takeaways. I don't want to necessarily just talk about what throughput and latency we saw. I'm sure there are better published resources out there which tells you the throughput and latency numbers. What I want to talk about is how running these performance tests basically helped us to gain confidence first of all for using Pulsar in production, and also in learning and understanding Pulsar's internal mechanisms when it comes to how different components interact within Pulsar. We would go in with a particular load, which I showed you before, run it through a particular spec, and more often than not something would break. We would go in and check what's happening, what are the errors and warnings pointing to, learn about, and that would be an opportunity to learn about how Pulsar handles some things internally. Over time, it gave us pretty good understanding about what are the different JVM settings that you should have in place, what's the ideal heap size, what is the what is the direct memory I should be allocating to, let's say, brokers, or bookies, or to Zookeeper. What are the configurations I need to put in place to prevent any bad actors from just taking over a lot of resources and bringing down the entire cluster. We also had awareness of the upper thresholds of our persistence layer in this process, right? We were using EBS volumes for storage. We were kind of hitting the upper limits of what was capable by the provisioned EBS disk. So by tweaking the throughput and IOPS that are being provisioned, we saw some changes in our performance numbers. But for running these tests we wouldn't have known. We also got to know about the read and write cache. How do you maneuver and think about the read path overall, right? What are the different components in that read path that you can tweak to improve your performance? Same with the write path, and more importantly, what are those configurations that you might want to think about and have readily available when a production scenario comes up. Lastly, and this is something that we are still making an effort to learn and do and learn better and do a better job of, is to understand how garbage collection, major and minor compaction overall works within Pulsar. To me, it's not straightforward. I'm sure there are better resources that if somebody is familiar with can point to, but more on that in a bit. I'm going to skip on this. We didn't really go ahead with the dashboards that are available out of the board for observability. Instead of using Grafana, we have integrated the backend clusters, all the different components with what we use internally for all of our other services on New Relic. What I really like about using New Relic for observability is you could write SQL based queries and you can have and create alerts for instant action, all in efforts to not wake up at 2 o'clock and wonder why is Zookeeper down. All of this have kind of situated us good enough to be positioned for growth. And talking about growth, we just went live in May, as I said, but we have a pretty exciting roadmap, and all of the features that we have on our roadmap for this year and for later next year are all based on core Pulsar functionalities, which we are going to utilize for Boomi's specific needs. We might have a custom solution for it, and we look forward to contributing it to the open source when we get there. Overall, I think, as I mentioned, we had pretty good success with it, and we had major learnings along the way, right? As I said, it was not all smooth sailing. We had some challenges that we came across. The first one again being, understanding Bookkeeper can be a little tricky. How a particular scenario that happened was when the disk or when Pulsar goes into a read-only mode, that's when all of its disk is saturated to a certain extent. Even if you increase the disk space, we found that and delete all of the backlog on a particular namespace, the content and the disk space was not relieved. And this was even after all of the messages were marked for deletion. Something that we are still looking into and working on, and understanding the ideal performance tuning methodology. It's more of a I think it's more of an art, and to come up with pretty good JVM numbers and to determine what should be the pod resource limits, what should be my EBS disk IOPS, so that I'm not over provisioning and also not under provisioning for different requirements. I think I saw somebody talk about the auto scaling for bookies and volumes in morning's presentation, but that's something which is not available right now in the version that we are using. I think we are on 2.11.2. Scaling bookies is a challenge in that environment, and something that we want to share with the open community is, and if you can all do a better job around wherever there are documentation gaps and there are some critical functionalities that we think are hopefully they're addressed in this next major version that's coming up, 3.1 and above, are around one that we kind of determined or came to know towards the end was some of the critical topic level stats. I think I spoke to somebody in an earlier presentation about some of the critical stats that we were using for usage based calculations of a topic. They get wiped out when a broker is restarted, and within Pulsar, brokers are stateless, and that's one of the positive of having a Pulsar broker, that you can get rid of them, get a new one whenever you want, but that should not happen at the cost of losing out on historical data like total message count of a particular topic. That's, that's kind of important for us to know. And if we can also see and know if there are better tenant level limits and policies that can be put in place to determine max rate in, max rate out, and to also determine how much disk space is a customer, at a customer level, at a tenant level, how much disk space are they using, and if we can limit that without having to run an aggregation of all the topics and under all the namespaces. If there could be tenant level policies, that would be also amazing. And lastly, we are a new team, we are a new product within Boomi, and if there were resources and articles or blogs maybe which would be out there, which would tell us how do you better balance your cost, right? We have 3 different regions. We have, each region can have multiple environments, which means multiple clusters. So the math kind of there doesn't add up, it kind of multiplies, right? Because each region has 3 times 3, so now we have to maintain 9 different clusters. So the cost kind of adds up there too. So you might ask, how is it going? We have been live for about 5 months. So far we have had about 500 plus customers self provision and get on board to this solution, which is roughly around 800 tenants. We have about 1000 plus namespaces, 3000 plus topics, and we also are supporting around 4.2 million messages per day that go through our broker. And overall, from a product point of view, we have seen a 58% improvement in our Gartner's critical capability score, which is a big boost for Boomi in the iPaaS vendor landscape. And something that helps me sleep very well at nights is that so far we have had 0 outages, and hopefully it stays that way too. And I just want to wrap my talk up by saying the community over here is really amazing. We were here last year at the same conference, where we started off from scratch, and with the help of all the resources, training materials, courses, YouTube videos, and for that one really great resource which tells me, for that one really great articles which tells me how to do performance tuning. We are really thankful for all that support. I've seen the Pulsar Slack as being one of the most active Slacks, and where you get your questions answered, pretty quickly. And again, just want to say thanks for all the continuous development and improvements that are happening on Pulsar. We aim to also contribute and grow with the community over here. With that, thank you very much. I'm open for questions.